Good morning, my dear students. How are you? Hope you can all hear me. Hello, grade 7. Can you hear me?
Yeah. Miss, can I ask you a question?
Yes, of course you can ask me anything.
Miss, do we have a quiz next week or no?
Yes, we do have a quiz next week.
We do, we don't have any quizzes next week?
No, we will have a quiz next week.
When?
Guys, you will find all the details on the SMS, but it will be on Monday during our session.
Monday?
Yes, next
On
Monday.
what, Miss?
On chapter 1, on chapter 15, lesson 1.
Okay, Miss.
It's gonna be an easy quiz, guys. Do not worry about that. Just let me check the time for you. It will be, inshallah, at 11:20 on the 5th session. Okay, for those who are taking the quiz online, we will do the quiz at the same time as the online session. You'll find all the details on the SMS, okay?
Okay, Miss.
Okay. So guys, let's continue what we finished last session and also the last video or last recorded video on the YouTube. So we started lesson 1 on chapter 16, which is talking about the sound and how is the sound produced. We learned not new vocabularies, but we kind of recapped all of them again. Again, what is sound? As you learned, it's a longitudinal wave, and you know longitudinal wave is a type of the mechanical waves that can only travel through matter. And we learned that every sound must be done by the vibrations, like we learned about the guitar strings in here. When we pluck them, that means we are vibrating them or causing vibrations to happen to them. And since they vibrate, the particles around the strings will also vibrate. Can you guys see my screen?
Yeah.
Yes.
Okay. We also had a reminder of the longitudinal wave, and it's the type of wave that where the particles move in a parallel direction with the wave itself or with the energy itself. Um, as you learned before, it's the one where vibrations are back and forth, not up and down. Okay. You also learned before about the word medium, which is the material through which the wave will travel. And since sound wave is a longitudinal wave, which is a mechanical wave, that means it needs a medium to move through, a material, a matter to move through. It needs anything, solid, liquid, or gas. It cannot move through empty spaces. And since it is a longitudinal wave, we have parts in it where the particles are closer to each other, which we call compressions. And you learn that when the speakers, since the speakers, if you touch them while they are working, they move um, back and forth. Um, this is what causes the compressions and rarefactions to happen. So when the speaker moves out, which means it's pushing the particles causing them to get closer, like in here. Change my pointer for you guys. Like in this part of the wave, can you see? This is where the particles are closer to each other because the speaker vibrated in back and forth. So when it went out or moved out, it pushed the particles, causing them to get closer to each other, as you can see in this picture. Not like the other part of the particle, which is the rarefaction in here. The speaker moved back, causing the particles to have spaces between them. Okay? Can you guys see the difference between the two images? Again, in the first image, where we have compression, as you can see, the speaker moved out, which means it pushed the particles, so they made this area of the wave where the particles are closer to each other, okay? Not like on this other side where it's normal air pressure. There is nothing affecting this part. So the speaker turned on, it pushed the particles, causing them to get closer, which we call compression, or the part of the wave where particles are closer to each other. But in the next picture in here, as you can see, the cone or the speaker cone moves back, causing the particles to have less pressure, and now they have spaces between them. So now we have rarefaction, where the particles are away from each other. So can you see how the vibration or the type of vibration affect the wave itself? The speaker here moves back and forth, which is a type of vibration, causing compressions and rarefactions. Not like in the transverse wave where the particles were moving up and down. Can you guys sense the difference? Guys, can you sense the difference here? Yes, so do you have any questions about this part?
No.
Okay, everyone with the same no, or do you want me to explain it again?
No.
Okay, we also learned about the speed of the sound and how it is affected by two factors, which is the density and how stiff the material is. For those who were in the physical sessions, I believe you do remember this because I repeated this again in the session. We said the density is how closely the particles are. Remember? You learned before in the last sessions that solids, for example, do have particles way closer to each other, not like the liquid and gas. Just give me a moment. I will stop sharing the screen, guys, so I can show you a picture in here. We are back, guys. If you looked at this picture closely, you'll find the solid in here where particles are closer to each other. Can you see? Can you guys see the picture?
Yes.
Yes, can you see my screen then?
Yeah.
Okay, in the solid in here, you'll find that particles are way closer to each other, which means that the energy will not take that long moving between them or through them. You learned in lesson 1 that waves are an, an energy that um, moves through particles, but they do not move the particles themselves. So since the spaces between the particles and the solid objects are so small, that means the energy will not take a long time to move through them. Not like in gas, for example. Can you see the spaces between the particles? That means the energy will take longer time to move through them. That's why density, which is how closely, what is meant by density, it's how closely the particles are packed next to each other. So as you can see in here, the gas is where particles are way far from each other, not like the solid one. So when the density increases, that means the particles will get closer to each other, letting the energy move way faster. That's why the sound moves faster in solid. Here goes not saying louder or softer sounds, but we're saying the speed of the sound itself. So the sound moves faster in solids, not like liquids and gases, because in the solids the particles are closer to each other, which will make it way faster to move between the particles. I hope you guys get this point. If you still have a
Yeah.
problem with it, if you still have a problem with it, you can tell me. Okay, guys, I hope you don't have any problem understanding this point. So density is one of the factors that affect the speed, as we said. We also have the stiffness of the metal, the material itself, or how hard is it. For example, we have our headphones. Most of our headphones are covered with a rubber material, right?
يا دخل
Yes. And this is a great example of how rubber actually blocks the sound or kind of stop its speed, like limits its speed. That's why when they start building, for example, a room that is soundproof, they actually use rubber stuff to, you know, stop the sound from getting out of this room so we can have a soundproof room. We cannot use metal, for example, because it's so hard or so stiff that will allow the sound to move through it easily, not like rubber. Okay, that's why when we lose this rubber coverage of our headphones, the sound of the headphones are so hearable by the people around us. Not like when it's with rubber object itself, with rubber coverage we're talking about. Do you guys get this one?
Yes.
Show to you. Mhm. Can you guys see my screen right now?
Yeah.
Yes.
Yes. And here you can find all the headphones covered with this rubber coverage surrounding the
To isolate you.
yes, exactly, to isolate the sound, because it's not as stiff as the metal. It's way softer than the metal, so it does not allow the sound to move that fast through it. So now, guys, you learned about the two factors that affect the sound speed, which is the density, how close the particles are, is it solid, liquid, or gas? And the second factor is how stiff the material is. So if it's so stiff, it will allow the sound to move faster. But when we have rubber around it or soft materials, then they will, stop the speed of the sound, or we can say decrease the speed of the sound, isolating it like your friend said. I hope you guys get this point. You still have any problems with it? I hope you don't, guys. Okay, so in here, guys, he's explaining that the sound moves way slower in the gas and liquid materials, but it moves the fastest in the solid materials. So we can say it moves the fastest in solid materials, but slowest in the gas. Okay. We also learned that it moves faster in the seawater, not like the fresh water, because seawater means it's filled with more salts, right? That means more particles inside them that will allow the sound to move faster, not like the fresh water. Let me show it again for you guys in here. Can you guys see my screen right now?
Yes.
Yes.
Yeah.
On the left in here, guys,
Yes.
we have the seawater. Can you see the particles of the water? The particles of the water. Between them, there are the salt particles. Okay, that's why the sound moves a lot faster, because the particles are closer to each other, not like in the fresh water where there is less salt in it. That means the seawater, the one on the left, has more density because its particles are way closer to each other, allowing the sound to move faster, while the fresh water is less density because the particles are way far from each other, not allowing the sound to move at the same speed as it moves in the seawater. You guys get this one too. Do you guys get this one? I hope you do.
Yes.
Yes, the temperature also, guys, temperature also affects the sound speed. Like if you looked at the timetable in here, you will find that air, for example, with high temperature, can you see the one with air 20 Celsius, which means with higher temperature, not like the 0 Celsius above, you'll see that the sound will move way faster in the air with high temperature, because the material or the matter with high temperature means the particles will have more energy and they will move way faster. Do you get this one? With more temperature, that means more energy for the particles of the matter that will allow them to transport the energy or the sound energy as fast as they could. Give me a second also, guys. Can you guys see my screen now?
Yeah.
Yeah. So this is a matter or a material where you can see the particles inside of them. Can you see that when we add temperature to it, the particles start moving way faster? Can you see this one? So if we add heat or temperature to the matter, the particles will transport the energy way faster now, because now they are moving faster because they gained energy from the heat. Do you guys get this point?
Yes.
Okay. So we learned that as the temperature increases in gases, the particles will move faster, like in air, right? It will take less time. But in liquids and solids, it's totally the opposite. Okay? Like if you looked in the timetable here, you find the water with higher temperature has less sound speed than the water with less low temperature. And ice also, and iron. Okay guys, so temperature increases. That will allow the particles to move way faster, which means it will take less time for the sound to move through them, but that happens only in gases, not in solids and liquids. Okay? Do you guys get that point?
Yeah.
Yes. So when we say here, this is that question, a very important question. Why does sound travel at different speeds through different materials? We'll say because it depends into two factors: density of the material. You can go back to the answer in here. Because the sound speed depends on two factors: the density of the material, which means how close the particles are packed together, and also how stiff the material is. How hard is it? Okay, so when we have a question like this, now guys, you know it's easy to answer it. Why sound travels in different speeds in solid, liquid, and gas? Why doesn't it travel in the same speed through the different states of matter? Now we know it depends into two factors: density and how stiff the material is. Okay. Okay. Now we'll move into the part where we said we continue today, inshallah. Detecting the sound. How do we get the sound? How we feel where's the sound coming from, and so on. And that of course depends on one of the most important organs in our bodies, which is the ear, right? Okay, we have three parts of the ear. We have the outer ear, the one we can feel with our hands, the one outside, okay? And we have the middle ear and the inner ear. And each part of the ear does a certain job. The outer ear, for example, collects the sound waves. So if you try to cup your hand around your ear, for example, if you're trying to hear something, and this thing is so, with soft sound, you try cupping your hands, right, around your ear. That will allow you to hear more because now you are collecting more sound. So the job of the outer ear is to collect the sound. That's why it has a kind of curve inside of it. Okay? The middle ear amplifies the sound. It kind of, make it a lot better. The inner ear sends the signals to your brain so it can detect the sound, whether it's a car sound or your mother's sound, because you know that our brain keeps a memory of the sound in it. Let's look closely at the inner part of the ear. You can see the outer one. We said it collects the sound as we learned in the previous slide. Okay. It gathers more sounds. As you can see, it's gathering the sound coming inside of it. The canal in here, guys, this canal in here, can you see it? This one in here is also a part of the outer ear. Okay, and since the outer ear collects the sounds, the canal directs them into the middle ear. Now we have the middle ear. In the middle ear, which amplifies the sound, you will find the eardrum. You see the eardrum, this thin skin-like part of the ear. It's so thin, guys. Okay, so we have the eardrum, which is like a drum head. Okay, we have the 3 bones in here. So when the sounds get into your ear, or collected by the outer ear, and then they are directed by the canal into the eardrum also starts to vibrate. Okay, and these vibrations will move through these 3 bones in here. We have 3 bones in here. We have the hammer bone, the anvil, and the stirrup, as we learned about. Okay. The vibrations of these 3 bones will then connect the sound or get the sound toward the inner ear, which contains the cochlea. We can say it's an article called cough. Some people actually have problem with cochlea that they needed to be transplant in them. Okay, so again, guys, we have the outer ear collecting the sound, and then the canal, which is a type or a part of the outer ear. It directs the sound or vibrations, to be specific, to the eardrum. And the eardrum is a part of your middle ear. When the eardrum gets the vibration, it also starts vibrating, transporting these vibrations into the 3 bones behind it, which is the hammer. This first bone is the hammer, second one is anvil, and then we have stirrup connected with the cochlea, which is the part of the inner ear. Okay. So the inner ear, as we said, contains a chamber, or we can say fluid-filled chambers filled with liquid-like structure. We call it cochlea, as we said. The sound wave will pass through the cochlea, cause tiny hairs inside it to vibrate, and this movement will be then sent to your brain. So inside the cochlea, guys, we have tiny hair that will vibrate also, sending signals to your brain. Okay, so the brain now can get the signals and tell you the direction of the sound, stalking, and everything, if this sound is known for you. Do you guys get the part of the human ear?
Yes.
Do you have any questions about this part?
No.
I will upload the video, inshallah, after the session, so you can watch it again. And guys, all the videos of the previous sessions are uploaded on the SMS. You'll find all the links for them. Okay, so you can re-watch them as a revision for the quiz. And if you have any questions, you can send it to me. Okay, before the quiz, inshallah. It will be on chapter 15, lesson 1, which is only talking about waves. It's going to be, inshallah, easy one. And I know you are up to the challenge, right? So you have all the videos, and you also have the study sheet with you now, which is the same PowerPoint, and you have the worksheet, okay?
This is their homework.
Yes?
Their homework.
Can't hear you, sweetie.
Their homework.
I can't hear you. There is a lot of noise.
Is there a homework?
You have a worksheet on the SMS. We will try to do some of it now. But before that, guys, I have to tell you that when you have a really loud sound, it can make the eardrum vibrate so hard that it will tear apart. Okay? And that's, of course, will cause us to lose hearing. Also, if you have infection inside our ear, if we hurt ourselves, or some people put their fingers or solid objects inside their ears in order to, I don't know, clean it or play with it. I have no idea why people do that, but you're not supposed to put anything inside your ear. But when you do so, you can get infection, and then it will also cause the hair cells in the cochlea to function less than they're supposed to be, and that also will make your hearing less sensitive, so you'll not be able to hear so fast. People working in airports, they wear like sound blockers around their head. Like they look like headphones, but they actually used to block the sound. Um, People working in factories where loud noises from the machines actually suffer from this problem. You will find them that with time they start losing hearing, and you need to speak really loud so they can hear you. That's why, guys, we are not allowed to put the headphones with high sound. That's why the phone gives you a warning sometimes telling you that it's too high for your human ear. That will cause damage with time. Maybe not this time, not the next one, but one day with this loud voices or loud sounds you're hearing, it will cause you to lose your hearing ability. Okay, guys? Do you have any questions before leaving this one?
No.
Do you have any questions before leaving this one?
No.
Okay, so I hope you can see the worksheet in here. I will upload it with answers after the session. So let's start with the first one. In a longitudinal wave, particles in the medium move in the same direction as the wave travels. So you guys can raise your hands if you would. So again, it says in longitudinal wave. Well, longitudinal wave is a type of mechanical wave. We know that. But are the particles moving in the same direction that the wave travels? Or is it moving up and down? This is a true or false, guys. So in the longitudinal wave, it's the wave where particles move parallel, remember, parallel to the wave direction. So it is, yes, moves in the same direction that the wave travels. This is true one. Guys, I'll wait for you guys to raise your hands. The next question is so easy. Sound waves can travel through empty space. Yes, what?
False.
Yes, because sound is a longitudinal wave, which is a mechanical wave, and mechanical waves cannot move through the empty space. They need a medium to move through, or a matter to move through. Thank you so much, Wei. Sound waves carry energy away from the source. True or false? Yes, Ahmed?
True.
Yes, that's right. All the vibrations carry the energy away from the source. Okay? The greater a medium's density is, the more slowly sound travels in it. Yes, Adam?
False.
Yes, false, that's right. Because when we have more density, that means the particles of the matter will be closer to each other. That means they will not take the same time. The sound will move now way faster. Okay, in humans, the function of the inner ear is to amplify sound. The function of the inner ear is to amplify the sound. Yes, Rahma?
False.
False, that's right. The job of the inner ear is to send signals to the brain. But the inner ear, but the middle ear is the one that amplifies the sound. That's right. Thank you, Rahma, not the inner ear. Okay, now we'll choose, this is choosing, which scale is used to describe the loudness of the sound. And this one is from lesson, the next lesson, but we learned about it in the chapter 15. Which scale is used to describe the loudness of the sound? It's decibel, guys. So as we measure distance, for example, we say it's kilometer, right? Right, 1 kilometer, 2 kilometers. When we describe the weight, the weight of something or the mass of an object, we say it's kilograms, right? But for the sound, the scale we use is decibels. Okay, so it's going to be the decibel. Okay, guys, let's move to the second one. Why do sounds of the same pitch made by different musical instruments sound different from one another? This is we're going to learn about in the next lesson, not this one, so we'll leave this question. Okay, let's move to, okay. Number 5, sound waves carry energy, and particles from place to place. What do you think, guys? Yes, Karim. I can't hear you, sweetie.
Energy.
Yes, energy, that's right. Carries the energy. That's right, Karim. Yes, does not carry the particles, but they move through the particles, but they do not carry the particles or change their positions from one place to another. They only carry the energy. Thank you so much, Karim. Okay. We'll learn about the wavelength and the amplitude of the sound waves. Okay, not generally, like you learned about them generally in the lesson 2 in chapter 15, but we'll learn about them but for the sound in the next lesson, inshallah. So we'll leave these two things, these two questions. We'll move to the questions where I want you guys to answer. Okay, number 9. This is an easy question, but it needs more thinking, though it's so easy. It says that which motion best describes how the particles in a medium move when a sound wave, this is the answer, guys, a sound wave moves through the medium. Yes, Karim.
Up and down.
I shoot up and down. Well,
Back and forth.
yes, back and forth. Thank you so much, Wade. Yes. Karim, or those who picked up and down. Up and down is for the transverse wave. Remember the transverse wave that move in perpendicular to the wave direction, which means they move up and down. Okay, the particles will move up and down. But the sound wave, that's why I told you guys sound wave is the answer for this one, because sound wave is a longitudinal wave. Longitudinal waves move parallel to the wave direction, which means they move back and forth, like the speaker we saw before. It moves back and forth. Okay? Okay. Thank you so much, Karim, and thank you so much,